All right. So we are live right now. I hope I'm audible to all of you, right? Just let me know if I'm audible or not. Hello, guys. Am I audible to all of you? Okay. I see I'm audible. Okay. And I'm visible to all of you as well, right? So I welcome you, all of you, to this amazing platform of TUTOR learning. So once again, we are back on this particular platform, and today we're going to discuss about the properties of definite integrals along with the lecture we had it yesterday, right? So if you haven't watched the previous sessions, I would request all of you to please go to the channel. First of all, please subscribe the channel and please like this video, and also please go to the platform and check out the playlist on integrals, right? So if you are not watching the channel, the videos step by step, you won't be able to understand the content of this particular sessions. Okay, so it is very important to basically go with the flow, and then only you will be able to understand the each and everything that is basically covered in this particular sessions and lectures. Okay, and trust me, if you are following the sessions along with the homework problems and everything that I'm giving on to all of you in this particular topics and these video lectures, you will be easily able to clear your JEE Mains and JEE Advanced examination. And these lectures are basically focused especially for the upcoming JEE Mains and Advanced 2026. So I hope that makes you very clear to all of you. And with this particular thing, let's get started. Okay. So if you have been watched the previous session, in the lecture number 3 or the last lecture that I took it yesterday, I mentioned some of the important property regarding piecewise defined function, right? So I explained these all properties regarding the piecewise defined function, and then I gave you some homework question to practice, right? So please let me know in the live chat how many of you have solved this homework problem. Please let me know in the live chat how many of you have solved this homework problem. So let us quickly look into the solution of this homework problem so that we can look into the answers as well, right? So if you look at the first problem over here, it's a very simple problem, and it is basically, again, it is not continuous. Sorry, it is continuous, but it has a different definition of function. Okay, so if we look at the integral from 0 to 2 for the given function f of x dx, I can break it in different intervals like 0 to 1. For 0 to 1 it will be x squared dx, and from 1 to 2 it will be square root of x dx, right? So this is how I'm going to split the limit of the function, and accordingly I'll put the definition of the function, and then I will carry out the integration. So if I carry out the integration, the first answer is going to be 1 upon 3, and the second one is going to be equals to 2/3 of 2 root 2 minus of 1. So that is how what we will get the answer. So if you combine this and if you simplify, the final result is going to be equals to 1 upon 3, 1 upon 3, 4 root 2, 1 upon 3 and 4 root 2 minus of 1. 1 upon 3 multiplied with 4 root 2 minus of 1. I hope you have all got the same answer. I hope you have all got the same answer. Minus, sorry, 1 upon 3, 4 root 2 minus 1. Is it clear to all of you? Is this clear? Please give me a thumbs up or yes or no. Tell me yes or no in the live chat. Is this clear or not? Right. So I hope this particular solution is clear, and this is how the simply you can solve these questions. Okay, whenever you have multiple definition of functions in different intervals, this is how you actually have to solve the question. Similarly, if I talk about the second problem itself, the second problem is also a very interesting problem on modulus function. So if I talk about the second problem, now before I talk about second problem, by definition of modulus function, so by definition of modulus function, I can write mod of a minus b as equals to b minus a for when your a is less than b, and I can write it as b a minus b when your a is greater than b. Okay, so these are the simple definition of the modulus function. So if I keep this in mind, then I can write 1 minus x as, so it will be simply as 1 minus x when your x is, so when your x is less than equal to 1, and since our limit starts from 0 to 2, I can put it over here from 0 to 1. And when it is from 1 to 2, it will be simply x minus 1. Okay, when it is basically in the interval 1 to 2. Okay, so based on this particular definition of the function, now I can integrate this given function from 0 to 2 mod of 1 minus x dx. I can integrate with different definitions in different intervals, and it is starting from 0 to 1. The result is 1 minus x dx, and from 1 to 2 the result is x minus 1 dx, right? So therefore the result is gonna, if you just simplify it, the result is gonna come out as equals to 1. Okay, now there is one more easier method to solve this question. Now since you all know that definite integral implies it is basically the algebraic area, right? So similarly what I will try to do over here is that I will try to plot the graph of this function in this particular interval 0 to 2, right? So what I will do over here is that if I try to plot the graph of this function, if I try to plot the graph of this function, this is my x, this is my y. So 1 minus x, first of all, let me plot the function 1 minus x. So 1 minus x is basically like this, right? Right. So I have to invert the part of the graph which is below the x-axis to the up when we take the modulus, right? So the final graph will gonna look like, is gonna look like something like this, right? So the dotted line represent the final graph, right? So this is my final sections from 1 to 2, right? So at 0 it will be 1, and at 2 also it will be 1, and at 1 it will be 0, right? So ultimately our area of interest is basically this particular region when I take the mod of it, right? So this is the region that I'm interested to calculate the area of, right? I hope this is clear. So if you just calculate this area of this interval, so this area, this is 1 and this is also 1, right? So area of this particular region is basically area of this two triangle, like first triangle plus second triangle, right? Which is equal to half times 1 into 1 plus half times 1 into 1, right? So that is equals to 1 square, right? 1. So therefore, the answer to the definite integral is equals to 1. So this is how you can also proceed the question, right? Is this clear to all of you? Is this question clear to all of you? Please let me know in the live chat, is this question clear? Okay, so I hope this question is clear to all of you. Let's now proceed with the next thing. The third problem is basically cosine of x and we have mod of it, right? So similar to the problems we have approached, you have to find out the interval in which the cosine is positive and negative, right? And then you have to change the functional definition accordingly, right? So I hope this will be also an easy question. And similarly, the question fourth will be also an easy question where you have to again find the interval where your y is positive and negative, and then when you put mod of it, the negative region becomes a positive region, right? So that is how you're going to transform the function and you can do the solution as it. Okay. So I hope that is clear to all of you. And the last problem where I asked you to integrate x minus greater change of x. Now you must have all studied that the function x minus greater change of x is basically can be given as fractional part of x, right? Fractional part of x, right? So with this particular thing also we can solve the question. But if I just apply the question like as it is, so x minus greater change of x, and I just integrate within the interval, within the interval minus 1 to 1, right, dx, then I can first of all split it, and minus 1 to 1 x dx, which is equal to 0, minus of greatest integer of x from minus 1 to 1 and dx, right? Now I can do multiple ways. I can also plot the graph of it and then I can go do the solution, right? So similarly, so if I, so this particular function is an odd function, so this is on going to be 0, but this function from minus 1 to 0, from minus 1 to 0 it is going to be equal to minus of 1, and then from 0 to 1 it is going to be 0. So ultimate answer is going to be minus 1 times minus of 1, right? So which is going to be equal to 1, which is going to be equal to 1. Okay, and if you do it by the graphical approach, I know how you can plot the graph of the fractional part function. So fractional part function graph is something like this. This curly bracket denotes the fractional part function. Okay, so okay, so like this, you have to plot the graph and then you can find out the given area. This is the area that you need to find out. This area and this particular area. Right. So this is again are two triangles whose areas are half and half. So you sum it up, you get the equal to 1. I hope this all homework problem solution is clear to all of you, right? Is this clear to all of you? Please let me know in the live chat. Please let me know in the live chat. Is this clear? Is this clear? Is the solution of the question clear to all of you? Okay. So with this particular idea, let's proceed with the next topics. Okay. So I hope these questions are clear, and then if you try to solve any types of questions based on these properties, I hope you will be able to solve it very easily, right? And also please keep in mind whenever you do like piecewise given function or like discontinuous function, it is very helpful if you can plot the graph of those functions and then you can proceed with the solution. Okay. So keeping all those things in mind, let's proceed with the next part. Okay. So now I'm going to discuss a very interesting problem, and this is a JEE Advanced previous year problem. Okay. So the problem is very interesting, okay, and you can all mark it as very important problem as well. So the problem is you have to integrate from the limit 0 to 100, and it is given as tan inverse of x. It is given as tan inverse of x and greatest integer of that. Okay, now to make the question really challenging, the paper setter actually gave it at greatest integer of tan inverse of x, right? So that you can actually integrate that function, right? Okay, so if I have this question, how am I going to solve this question? Now, in order to solve this question, there is some kind of graphical transformation related to it that you need to understand, and that will be a base for, especially if you are going to solve JEE advanced based problem. Okay, so something called as graphical transformation, when you transform any functional expression to its greatest integer functional expression, right? So this kind of graphical transformation is very, very useful, especially if you look into the recent days JEE advanced questions. Okay. So recently in the JEE advanced problem, they will see a lot of questions in definite integral have been asked where they give a function, where they give a tricky function and they put a greatest integer of it. And then you have to integrate within the given limit, right? So the simple method is basically you have to first of all find the regime in which the functional equation or the function inside this greatest integer is lying in, right? So if you find out that particular region where this inside function is lying, and then when you take that transformation or when you to put the greatest integer of it, you are able to simplify this function in the following limits, right? So you have to first of all do that particular modification, then you can proceed with the area, right? So let's see how we can solve this question. But before I try to solve this, I want all of you to please answer, like, is there any method that you can go with it? What is your preferable way you want to solve this question? Any answers in the live chat? I'm going through the live chat. Please let me know. लैग आ रहा है, वॉइस कट रही है. Is it clear now? Like, is there any method that you can? I think the lag is basically from your side. तन्मय, एक बार अपना लैग चेक करो, एक बार अपना इंटरनेट चेक करो, ठीक है? मुझे नहीं लगता लैग है. ओके, एक बार अपना इंटरनेट एक बार चेक कर लो, और या फिर आप ब्राउजर को क्लोज करके फिर से ओपन करो. ओके, रिफ्रेश योर यूट्यूब, देन ये ठीक हो जाएगा. ठीक है, ठीक है. तो ये जो क्वेश्चन दिख रहा है, राइट, दैट इज tan इनवर्स ऑफ x एंड वी हैव अ ग्रेटेस्ट इंटीजर ऑफ इट. सो टेल मी, हाउ एम आई गोइंग टू प्रोसीड विद द सॉल्यूशन ऑफ दिस क्वेश्चन, राइट? So the simplest method is, first of all, let me know how the tan inverse of x function looks like. That is my first step. Secondly, I need to see that in which region to which region, if I do the greatest integer of that particular function, what is my greatest integer value, right? So we all know, so from our previous knowledge of inverse trigonometric functions, so if I try to plot the graph of this function y is equal to tan inverse of x, so you must be knowing it that the graph of the function tan inverse of x, it looks like something like this, right? Right. So it is a bounded curve, and the upper bound of this curve is given as pi by 2 and the lower bound is given as minus pi by 2, but it does not, it is asymptotic towards pi by 2 and minus pi by 2. It does not equal to pi by 2, right? So if you look at there is one point where I'm getting, so pi by 2, if I analyze the data, pi by 2 is somewhat or approximately equal to 1.57, right? So in from 0 to, so if I observe the values in the y from 0 to 1 pi by 2, there is an interval where I'm getting 1, right? Now why I'm interested to look into the interval where I'm getting 0 to 1, because the output of this particular function tan inverse of x, if it is lying between 0 to 1, then the greatest integer of that is always equal to 0. Right, so we all know this particular thing. So if I have greatest of x, it is equal to 0 when my x is lying between, 0 and 1. Okay, so I am trying to figure out that in which interval of tan inverse of x is lying between 0 to 1. So first of all, let me do that particular thing. So if I try to find out tan inverse of x lying between 1 and 0, so I will need to find out this particular point in the x-axis, right? Now where most of the students make it wrong is that they answer this as equals to pi by 4, right? But that is the biggest problem that they do, right? So this is not equal to pi by 4, that you need to understand. Okay, so pi by 4, if you're telling pi by 4, it is wrong, right? Because don't forget, tan inverse of x gives the result for the angle, right? I'm not looking for pi by 4 angle. I'm looking for that angle whose value is 1 radian. So tell me that particular x for which I'm getting tan inverse of x as 1 radian. So if you do it, that particular value where you're getting 1 radian will be coming out as tan of 1. So if you put tan of 1, so tan inverse of tan of 1 is going to be 1 radian, right? Very careful, be very careful over here. I'm start marking this thing, okay? So this is very, very important. I'm start marking it, okay? So please be very careful about in this particular region, because most of the students I have taught over my years, so I have seen people are answering this value of x is equal to pi by 4. That is the wrong thing to do, okay? Because tan inverse of x returns the value of radians or the angle. So that is not pi by 4, right? So it should be tan of 1, so that I get the angle as 1 radian. I hope this is clear, right? So therefore, in between this interval from 0 to tan of 1, now tan of 1, this value is also less than 100. Okay, this value will be probably less than, obviously less than 100. So therefore, from 0 to tan of 1, so from 0 to tan of 1, the tan of 1 radian, this value is going to be 0. This value is going to be equal to 0. And in the remaining interval from tan of 1 to 100, whatever is the value is basically lying between, the value is going to lying between 1 and pi by 2. And I know that whenever my x lies between 2 and 1, the greatest integer of x is always equals to 1. The greatest integer of x is always equals to 1. So therefore, from tan 1 to 100, the greatest integer will be equal to 1, and therefore I will have the simple integration from this difficult integration to a simple integration like this over here. So this integration will give me the final result, that is the answer to this integral is equals to 100 minus tan of 1. So I will have the simple answer to this question, that is 100 minus tan of 1. I hope this answer is clear to all of you. Is this clear to all of you? Please let me know if this solution is clear or not. Okay. Because when I do the transformation in the greatest integer function, the greatest integer function of that tan inverse of x is going to look like, so I'm only plotting for the given interval. Okay, so it is going to look like in between 0 to 1, 0 to tan 1, it is going to be simply this 0. It is going to be simply 0, right? And and from tan 1 to 100, it is going to be equal to 1, right? So it is a step constant function like this. Okay, so ultimate area we need to find out is this particular area. I hope this solution is clear to all of you. I hope this solution is clear. Is the question clear to all of you? Is the question clear to all of you? Please let me know. Is this question clear to all of you? This is a very interesting problem, okay? Please try to analyze this problem again and again. And if you are having any confusion, any doubt anywhere, please ask me right now. Okay? Please ask me right now. I hope the solution to this question is clear, right? If you still have any question, please let me know. I'm looking your live chat. Okay, I'm going to the live chat. Please let me know. Okay, and please share these videos among your friends and your relatives so that they can also join the sessions and also join us with the question solving sessions as well, right? So whenever I give any question, they can also have the answer so that you can compete with your friends as well, right? So please share this channel as well as the videos with your friends who are preparing for JEE Mains and JEE Advanced for the upcoming session 2022, 26, sorry, right? And please, if you're new to this particular channel, please subscribe to the channel and hit the bell icon to never miss any upcoming notification, right? So every day on this particular platform, we are going to have live classes, especially for maths, chemistry, physics, and even we have our new channel, which is TUTE Learning NEET, where you are having daily biology lectures, okay? So please subscribe to that particular channel as well. That is TUTE Learning NEET. Like this particular channel is TUTE Learning JEE. So you also have another channel, TUTE Learning NEET, where their biology sessions are basically also going on, okay? So you can watch those biology lectures from that particular session as well, okay? I hope this question is clear to all of you. Please let me know in the live chat. Shall we proceed with the next problems? Shall we proceed? Okay, so let us proceed with the next topic. And now we're going to discuss about another property, that is application of even and odd property and half of the integral limit property. Okay, so similar to application of like the even and odd property we have seen in the previous session. So if you look at the previous session, we have discussed about the even and odd property, right? So the even function and the odd function property we have already discussed in the previous session. Okay, so please go back and watch the previous lecture to understand it, right? So now I'm going to discuss the property relating to, so now I'm going to discuss a property which relates to like half the integral limit. Okay, half the integral limit. Okay, so whenever we do the half of the integral limit property, okay, half the integral limit property. Okay, so that is something I'm going to learn today now over here, right? So what is that half of the limit property? Let's try to understand by simple definition of the property. So first of all, let me write the property definition over here. Yeah, so the property, so let me first of all write the property. So this is a property number 6 and let us sub name it as A. Okay. So the property says that if you have an integral from 0 to 2a, if you have any integral from 0 to 2a for the function f of x dx, then this can be given as 2 times of 0 to a 0 to a f of x dx if 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 I have f of 2a minus x is equals to f of x. So whenever I have this particular property existing, then I can write this as 2 times of 0 to a. So instead of 2a over here, I simply transform to a over here, right? So instead of just 2a, I transform to a over here. And similarly, it will equal to 0 if you have the symmetricity about 2a is equals to minus of f of x. Okay, so when you have negative of this, then it simply is equal to 0. Okay, now this particular property will actually help a lot in simplifying the questions of limits, okay, in definite integral questions. Okay, so let's see how we can quickly prove this particular result over here, right? So if I talk about the proof of this result, so if I quickly go through the proof of this particular property, so what I know is that when I write this limit, that is 0 to 2a for the given function f of x dx, I can simplify this limit from 0 to a for the given function f of x dx, and then from a to 2a for the given function f of x dx, right? I hope this is clear. Now I am simply going to do one modification, that is I'm going to put x equals to some 2a minus t. I'm going to simply put x equals to some 2a minus t. So if I do this transformation over here, then then I will have dx is equals to minus of dt. Then I will have dx is equal to minus of dt. So my result is from 0 to a f of x dx, which is remains as it is. But the second result, when I do it, it will go from, so if I put a, it will be equals to a over here, and it will be 0 over here, right? So the limit is from a to 0 now, and then the function is basically 2a minus t into minus of dt, right? Now we have already learned the very initial property, that is changing the limit of the definite integral, and then we have the minus sign, right? So I can incorporate for this minus sign, and I can do that. So it will be f of x, so f of x dx plus 0 to a f of 2a minus x dx, right? I just simply change the variable as well, right? So I use two properties over here, which I have already studied in the basics of the definite integrals, and therefore if now from here, if I have my f of x is equals to f of 2a minus x, if this thing holds true, then I can write this result as 2 times of 0 to a, because I have the same limit now, that is f of x dx, right? And if this particular function is equals to negative of f of 2a minus x, if this is equals to negative of f of 2a minus x, then this function, this integration is simply equals to 0. This integration is simply equal to 0 because they again have the same limits of the definite integral. I hope this property is clear to all of you. I hope this property is clear to all of you, right? Please let me know in the live chat, is this property clear? Is this thing clear to all of you? Is this property clear to all of you? Okay, so now with this particular understanding, let's discuss a question so that I can explain you how am I going to use that particular result, especially when I try to solve some important questions. Okay, so now with this particular idea, let's try to solve a question. So the question says that, so in the question, this is example number 2, we have the integral from 0 to pi, we have the integral from 0 to pi, and it is x upon 1 plus 1 plus cos square x. 1 plus cos square x. Okay, so that is the result of the integral, right? So we have to integrate this particular result and then within the limit 0 to pi, right? So let us say, so how do we solve this question? Now, before I proceed with the solution, now generally whenever people do not think about anything, I always say that try to think of applying the King's property. So if I try to think of applying the King's property over here, so if I just apply the property or the King's property, that is for the functional expression a of x dx from the integral limit a to b, then this is also given as from the limit a to b function of a plus b minus of x dx, right? So if I just do that, I will be from 0 to pi, it will be pi minus x upon 1 plus cos square x, 1 plus cos square x dx, right? Now which I can split it as, which I can again split as, so this is equals to I, right? Which I can again split this as 0 to pi, pi upon 1 plus 1 plus cos square x dx, and then minus of, right? And then minus of, now this particular term, that is x upon cos square x, is again going to be the same, that is an integral, right? So therefore I get an integral equation like I is equal to this particular integral minus of I. So if I take this minus I on the right left hand side, it will be 2 times of I, which is equals to 0 to pi upon. So the interesting part is that I got rid of this x, right? Which I've already seen in many problems of the King's property, right? So this is basically pi upon 1 plus cos square x dx, right? So after I have this particular thing, now I can solve the question as simply as, so now our I is basically equal to pi upon 2, which is coming out constant. Now 0 to pi 1 upon 1 plus cos square x dx, right? Now if you look at the interesting property over here, now if I consider this particular function, if I consider this particular function as some function of x, then then f of pi minus x is also going to be equal to x. This is something very interesting to observe over here, is that if I observe that this is a function value of x, then I get f of just the upper limit minus x is equal to the same function f of x, right? So you can check it out. So you can put pi minus x over here, and cos square is there, so it will again become cos square x, only the same function itself, right? So if I have this result, then I can simplify this limit. So this result is going to be pi, it will be pi by 2, 2 times of 0 to pi by 2 now. So what I did is that I did the half of the limit over here, right? So I changed the limit to pi by 2. And therefore I have this as right? So therefore, now I can simplify this question by taking a simple modification is that what I'm going to do over here is that if I divide both the numerator and the denominator by cos square x, so then this is pi times of 0 to pi by 2. So if I divide both the numerator and denominator by cos square x, then the result is going to be like sorry, secant square x divided by secant square x plus of 1, right? So I will have this result as secant square x upon secant square x plus 1, which I can use the trigonometric identities, because I have already seen these kinds of questions, especially in the previous chapter, that is secant square x, and then I can use the trigonometric identity secant square x is equal to 1 plus tan square x. So this will become 2 plus tan square x over here and then dx, right? So then I can assume tan square x as t. So if I assume tan square x as t and then secant square x dx will be equal to dt. So you have already solved lot of question of this kind. So ultimately finally the answer is going to be like pi upon root 2 into tan inverse of so if you do that transformation, t upon root 2, and the limit is going to be going from 0 to infinity in this case, right? So what did I put t as simply as tan of x, right? T simply as tan of x. So if I just put the limits, then the result is going to be like, so the I is going to be equals to pi upon root 2, and this result is going to be equals to pi by 2, So the final answer to this question is pi square upon 2 root 2. So the value of the integral over here is going to be equals to pi square upon 2 root 2. I hope this is clear to all of you. I hope this solution is clear to all of you. Is the solution clear to all of you? Is the solution clear to all of you? Please let me know. Is this solution clear? Okay, so this is a very interesting problem, and I hope you can solve this question by simply using some simple transformation. Now, why did I have to transform from 0 to pi by 2 instead of solving it by 0 to pi? In that case, if I keep the limit as same as 0 to pi, in that case, I won't be able to do this transformation, because at pi by 2, tan of x becomes not defined, right? So therefore, I need to break the limit of the integral to 0 to pi by 2, right? So if I break the limit of the interval or the integration from 0 to pi by 2, then only I am able to take this particular substitution, that is t is equal to tan x, right? Otherwise I won't be able to do that, right? So please keep these things in mind, otherwise this things is going to be really difficult, especially when you're solving in the examination. Okay, so these are the small things that actually makes your base. Okay, and you have to have a very basic idea about this particular concept, otherwise when you are solving the question actually in the examination, you will have a lot of troubles and difficulties. Okay, so I hope this idea is clear to all of you, and with this particular thing, let's quickly wrap up this session over here. And especially now in the upcoming sessions, we are going to discuss about another very important integral, that is, and I want that to be as a homework problem for all of you. Okay, so please try to solve this as your homework problem. Okay, and we're going to discuss about this particular problem, very important problem, and you will have to remember the result. Okay, that is 0 to pi by 2 integration natural log of sin x dx, and also try to find out the integral result 0 to pi by 2 natural log of cos x dx. Okay, so please try to find out these two problems. Please try to solve these two problems, and you will be interested to know that these two problems have the same answer, right? Because you can check it easily by using the simple King's property, right? By simple King's property, you can see both the answer are same. So I want you to find out this particular answer and let me know in the comment section. Okay, let me know in the comment section after this session is over. So I hope you will be trying to solve these questions and let me know the answer in the comments. Okay, so in the next class, when we're going to meet tomorrow, so tomorrow we're going to discuss about this particular problem, and then with that we are going to move into another important property of changing the limit from a to b to 0 to 1, a standard limit, right? So how we are going to do that, that is also we will be seeing up in the next upcoming class. And then with that, we're going to talk about the most important part, that is periodic function. So we're going to look into the properties of the periodic function, and then at the end we're going to look into the Newton-Leibniz rule, which is a very important rule, especially in the concepts and questions of limits. If you solve any questions of limits, especially for JEE Mains and JEE Advanced, when you see questions of limit involving integrals or definite integral involving variable limits, then those questions are very important. So we're going to discuss about those things as well in our upcoming classes. Okay, so with that I will be wrapping up the session, and at the end I'm also going to discuss about the Wallis formula. I promised all of you that I will definitely discuss about the Wallis formula, and we're going to also see how I can club integration as a limit of sum, and also we're going to see some small beta function, gamma function, and applications of some trigonometric inequalities. So with that, my sessions of definite integral will be over, and after that we're going to start with the new chapter, that is area under the curve. So we're going to take up three more lectures in definite integral to finish up this particular chapter. I'm taking up more lectures in integral because this is a very important chapter. This is a very important topic, especially for JEE Mains and Advanced. Okay, so with this thing, thank you for your attention to the session, and I wish you all the best for your upcoming preparation. आकाश द्विवेदी, मेरा आंसर गलत आ रहा है। एक बार फिर से लेक्चर को रिवाइंड करके देखो, ठीक है? एक बार लेक्चर को फिर से रिवाइंड करके देखो, फिर समझ में आ जाएगा, ठीक है? एक बार लेक्चर को फिर से रिवाइंड करके देख लेना, समझ में आ जाएगा। काफी सिंपल क्वेश्चन है, ठीक है? ओके आकाश? Okay, so with this, thank you for your attention and joining the session, and we'll meet again on tomorrow live again at this particular timing. So see you tomorrow in this particular channel of Tutee Learning, and please subscribe to the channel and hit the bell icon to never miss any upcoming content. Okay, and also if you want to study online in one-to-one mode or platform, or why do you want to take online coaching classes as like other students are basically preparing in a personalized way of preparation, you can always contact us in the number which is given in the description box. So please find out the number in the description box, and please contact us to get connected with me and my team, so that you can join us for a one-to-one online tuition. And so with this, thank you, and thank you all of